H2O2. That's the hydrogen peroxide. Okay. Let me try. Again, if it doesn't work, it's... So the way I will want to see if oxygen was really produced, so I will light up this splinter, just enough where it's glowing, and I'm gonna insert it inside my graduated cylinder. If this has oxygen, I can be able to relight the splinter. It's gonna catch flame again. So let me mix my catalase now. Bubbling, yes or no? Off. I need it. Anyway, let it bubble. Let it bubble. That's why nobody's sitting here, right? Should have used a smaller. Try it again. I mean, you've seen the bubble. You know it's oxygen. But first you fail. Fail again. Do it again. Oh, it might be because the oxygen is trapped there in the bubble. But I don't want to get it wet. Oh, there. You see it? Oh, we did something new. Okay. This is original. So, let's all watch this. Make it go, make it go. Ready? Maybe here. Oh, here. Fine. There. So I'm poking through the bubbles. You can try. I mean, I don't want to be the only person playing here. You want to try it? Here, I have a lot of splinters. Go, come. This is. There's more splinters. There's more. Nice. Nobody else wants to try.
This is so cool.
Oh, Harry Potter. They just have yeast and hydrogen peroxide.
This is so cool.
Harry Potter is just all chemistry. Explosion. And then something becomes big, just give it
라나 가가. 나내 꺼졌다.
So that's so dangerous, right?
No more bubbles. Here, maybe inside.
I'll try inside.
Oh, nice.
해봐 안에 해봐. 봐봐 방금 됐어.
혹시 무서워?
꺼졌다. 안에 안에.
Blow it.
Alright.
Well, I'm done playing.
With the flavor.
Let's go see Greta play.
Okay, I'm done. Thank you, miss.
그냥 뒤로 던졌는데 저거 이거 처음 인터 왜 브랜드 스타일
All right. Let's sit down. What was happening is we are we did break apart H2O2 into water and oxygen. Oh, all right. If I did not put this, we will not be able to form this. That's clear? It's not part of a chemical reaction. It doesn't mix with, well, it's mixing. It's not chemically reacting with H2O2. It just loosens the bond. So it's easier to break it. And I want you to look at your worksheet that we worked on, enzymes. Can you check your drawings? Like some of you, I put question mark. If there's no question mark, then you're fine.
Wow.
That's 3. Are you sure? Sorry. I have a question mark. First of all, which one is bigger? Your enzyme, Ellen, or your substrate? Enzyme, right? Check the drawing in the front. Many of you gave me pictures where the substrate is the same size as your enzyme. Please check. If you did, but I didn't put a question mark, please check that. Substrate is smaller than the enzyme. Yes? Okay. And maybe turn the paper. I'll walk around quickly. I don't remember the corrections. I think ask because we're going to have a quiz after the report. So let me give you a concept map, a map of 2.5. What are we learning here today? Ideally, if I do this in my grade 12, everybody participates. So let me see if you also going to participate. If not, I'll come. So 2.5, we're talking about enzymes. And I can divide the chapter into 3 things, just 3 things. First, we're gonna learn the action of your enzyme. How does it work? What happens? Then we're gonna talk about what affects your enzyme. What are the factors that affects your enzyme? And how does it affect the working of your enzyme? And the last thing we have to learn is the many applications and use of enzymes in industry. So fancy, it all starts with the letter A. I hope you can remember that because it's all A. Action, effect, and application. So how does it act? What affects it? And how do we apply, how do we use enzymes in industrial purposes? So what I normally would ask my grade 12 is, come up to the front. If you remember anything from your reading notes, like a phrase, an idea, a drawing, a graph, on the action, what affects, and applications of enzyme. Any from your reading. You can come up. I have markers here. Like write bullet points if you want in this area. Bullet point, bullet point. Action, effects, application. Or read through your reading notes quickly. It can be a phrase, it can be a word.